All right, everyone, we will go ahead and get started. Thanks again for joining us today. I hope everybody had a happy holidays and happy new year. It's a new year, but same mission for us here at SolidProfessor. We are really looking to become the all-encompassing engineering resource. And if this is your first time in one of these webinars, what we do is introduce a new course and our esteemed author that helped us create the course. And then we really just want to expose you to parts of what's included in the lessons. And our goal, again, if this is your first time joining us in one of these webinars, is to really, as SolidProfessor, is to really try and help democratize the knowledge that's available in this industry. And what that means is we want to be able to become, once again, the Swiss Army knife for engineering and manufacturing. And part of our goal is continuing to add new classes. So once again, it's a new year, but it's the same mission and vision for us. And a part of that is our author program. So we're going to introduce you guys today to one of our esteemed authors that helped us create this SolidWorks API course. So again, thank you to all of our members who continue to support us and give us great ideas on what new courses we should pursue, and we will continue on this mission. But let's go ahead and get started. My name is Bassanio Peters, by the way. I'm the Chief Content Ambassador here at SolidProfessor. And yeah, let's go ahead and get started. So what are we going to talk about? What are we going to cover today? Well, really quickly, we're going to introduce you guys to our author. He's an amazing author that has years of experience with SolidWorks API. We'll talk about what's covered in our SolidWorks API course, and then we'll actually show you guys a couple of sample videos and talk about what will be learned in those sample videos, including recording actions, model doc2 interface, and then some extruding features. And then in conclusion, we'll open things up to some Q&A. Expect this to be about anywhere from 25 to, can go up to about 40 minutes. And I'll say go up to 40 minutes because a lot of times there are a lot of great questions from the members who are listening in on this webinar. And again, if you do have to duck out during the Q&A session, you will be supplied with a recording to this webinar, so just in case you missed a few questions that you'd potentially be interested in. But without further ado, I'd like to introduce you guys to our esteemed author, Amen. Amen, take a moment and introduce yourself to our members and talk a little bit about your experience and expertise, what you currently do, and we'll kind of dive in and start talking about the course. But first, I'd like to introduce you as the author.
Thank you very much, Bassanio, and hi to everybody, and thanks for attending this webinar. My name is Amen Jlili, and I'm the author of the new SolidProfessor API course. A little about me. I originally qualified as a mechanical engineer from the University of Tunis. I was introduced to SolidWorks very early in my career. Today I'm a certified SolidWorks associate, certified SolidWorks professional, and a certified SolidWorks professional advanced sheet metal. And I'm also a SolidWorks API developer. So I do enjoy using SolidWorks a lot, but what I really enjoy doing the most is automating SolidWorks, whether that be through VBM macros or addings, and working on exciting projects with my customers in order to streamline and automate their CAD workflow. I'm also an active member of the SolidWorks API forum community where you can come there and ask questions. And I'm also currently the managing consultant of CAD Hero, my private engineering consultancy that provides industrial companies with SolidWorks design automation and services and training. You can reach me out at amen@cadhero.com or via Twitter at _cadhero. I look very forward to your questions and interactions this webinar, and with that, I'll give the floor back to Bassanio. Thank you.
Awesome. Thank you for that. And again, you know, part of this author program that we've created is because we can't be subject matter experts in everything. Everybody knows us for our SolidWorks material, and we reached out to Amen because of his subject matter expertise with SolidWorks API, and that's really the genesis of the author program and how we will become that Swiss Army knife for engineering and manufacturing. Before we dive into the rest of the presentation, I actually want to launch a poll question, and it is, do you currently use SolidWorks API? So if you have a moment, everybody that's logged in, just simple yes or no. You know, let us know if you're currently using SolidWorks API. All right, and it looks like a good majority of everybody that's voting has voted no. So this will actually be great because it'll give you great exposure to the actual API tool itself. So happy you tuned in, and we have about 87% of folks have voted so far. So we'll actually close the poll here in a few seconds. Oh, excuse me, we'll close that out. All right, so we have 79% say no, they have never had exposure using SOLIDWORKS API, and then the other percentage has said yes. So this is great, and that leads us directly to this slide, which is I'm going to ask Amen to just quickly go over, what's going to be covered in this course and what you're going to learn from this course, but most importantly, how it's going to benefit you in your day-to-day work and potentially automating some of the SOLIDWORKS processes that you do day in and day out. So Amen, just briefly tell everybody, what they're going to learn from this course and then what benefit it has to them in their day-to-day work.
So what sets SOLIDWORKS apart from other packages, other CAD packages actually, it's extensive, powerful, and yet very easy to use API. Nowadays, a lot of companies have very complicated and time-consuming tasks in their SOLIDWORKS-based engineering workflow, and the best answer to reducing the costs associated with that time-lengthy process and to increase productivity is to actually streamline this CAD process through design automation. So basically, the essence of this course will teach you the craft of dealing with all the different types of documents in SOLIDWORKS, whether you're designing a part that keeps repeating itself in your design process every time and you would like just a small button or a script that will redesign that part. You'll be also learning about sketching, assemblies, and drawings, and all of this comes with jump starting you into the VBA programming language. So back to you, Bassanio.
Great, thank you for that. And without further ado, we're going to dive right in. We're going to actually play you guys a series of videos really going over some of the key benefits, just a few of the videos, and kind of give you a sample of what you can expect to learn in this course. And I know that's part of the reason why everybody's here. So really quickly again, Amen, talk about what's going to be covered in this specific lesson covering the macro recorder. Tell the audience what they're going to be able to see and what they expect to see in this lesson in particular.
All right, so this lesson is one of the most classical steps to mastering the SOLIDWORKS API. An important component of design automation in SOLIDWORKS are macros, which are basically small scripts written in the VBA programming language. And when it comes to macros, we can basically record almost all actions that we can perform in the SOLIDWORKS graphical user interface. And SOLIDWORKS comes with a tool called the Macro Recorder tool that helps us record all of our actions and save it into a file, into a macro file that we can play later and repeat these actions that we have recorded. And that's exactly what we will be learning in this lesson. We'll learn about recording macros, using the macro recording, and playing these macros. Back to you, Bassanio.
Awesome, thank you for that. Without further ado, we'll actually go ahead and play this video.
In this lesson, we're going to learn how to record actions and run them inside SOLIDWORKS. We will automate together the process of creating a cylinder in an empty part document. Now, before we begin recording, I'd like to draw your attention to something important. SOLIDWORKS macros have what we call preconditions. They're basically the state of your SOLIDWORKS before recording or using a macro. In our case, we will take an empty part document as our initial starting point. Alright, let's begin. I'm going to go ahead and create a new part document. Click on the new document icon, pick the part template, and click on OK to confirm my choice. As you can see, we are now ready to record our macro. Let's go ahead and do that. To record a macro, go to Tools and then scroll down to the Macro menu. As you can see, we have a list of options to choose from. We can create a new macro. We can also edit an existing one. We can record a macro, and we can run an already recorded macro. Let's go ahead and click on Record. As of now, SolidWorks is recording all of our actions. You can also see that as soon as I hit the record button, a toolbar window appeared. This is the macro toolbar. This toolbar contains the buttons found under Tools, Macro. From this toolbar, we will be able to run a macro. This button has been disabled because we are in the process of recording one. We can also stop recording, and we can pause. Clicking on this button will pause the recording process, and clicking on it again will resume. Let's go ahead and create our cylinder-shaped part. I'm going to click on the Extruded feature from the Feature tab. Pick the front plane. Now we are inside the sketch mode. Let me select a circle shape and insert it to the origin. I'm going to pick a random radius. As soon as I'm done with that, I'm going to exit the sketch. SolidWorks is now asking me how do I like to create this feature. I'm going to give it a depth of 50 millimeters and click on Confirm to confirm the preview first and then to confirm the creation of this part. Now I think we're done. Going back to the SolidWorks toolbar, we can click on Stop to stop recording and save the macro. SolidWorks is now asking us where do we want to save the macro. Let's save it to the desktop. I'll give it a name of my first recorded macro and click on Save. Now I'm going to show you how to run the recorded macro. As we have said earlier, all preconditions must be fulfilled for the macro to run successfully. So let's go ahead and close this file and open a new empty part document. To play the macro, simply go to Tools, Macros, and click on Run. Let's browse to the macro file, select it, and click on Open. As you can see, SolidWorks is now running the recorded macro. Once it's done, by simply clicking on the Extruded feature, we can see that it has a depth of 50 millimeters.
All right, we'll actually dive right into the next video here, and Amen, same thing, tell people what they can expect to see in this lesson, and then more specifically, what are some of the benefits that you're going to get out of this function.
All right, so any macro basically you'd write or find on the internet begins with opening a document, creating a document, and when you're automating your design, you find yourself, as I said, opening a new document, opening an existing document, saving another one, or perhaps creating new ones. And in this lesson, we'll be learning about one of the most important interfaces called the Model Doc 2 interface that basically represents all types of documents. This would encompass assembly documents, part documents, or drawing documents. Back to Bassanio.
Awesome, thank you. Here we go.
In this lesson, I'm going to show you how to create, save, and open documents with the SolidWorks API. Now we already know that the SOLIDWORKS object is an essential part to any macro. So I have created a skeleton subroutine that gets us the SOLIDWORKS object ready for use. To create a new document, I've decided to use the iNewDocument2 method. It will return a model doc object if the document was created successfully. Now let's go and get more information about this method from the offline help. The first parameter of this method is a string type called template name. The template name parameter here represents the templates that you find under Tools, Options, and Document Templates. You can simply copy and paste these values into the method call. However, if we jump into the remarks section, SolidWorks is advising us to use the getUserPreference string value from the SOLIDWORKS object to get the default template file name. The reason behind this is that the location of these templates is a user preference. Every user can have these templates installed at a specific location, so using this method would make our code more general. Now this method will return the path of document template after taking in an integer value indicating which type of template we'd like to use. It can be a part, an assembly, or a drawing. For part documents, we'll use the SW default template part. For assemblies, SW default template assemblies. And finally, for drawings, we'll use SW default template drawing. Now we simply need to type in SW_const and then dot and then the name of these enumerations for VBA to evaluate them to their respective integer values. Now I'm going to define the following variable and call it part default template file name as a string type, and then I'm going to get the default template file name for part documents using the appropriate enumeration. After that, I'm going to define a new variable of type model_doc2 and set it to the return of the new document method. I will supply it with the part default template file name as the first parameter, and I will give zeros to the rest of the parameters. Great. Now let's run this and see what happens. Great. SOLIDWORKS has created a new part document. Now to save this document for the first time, we can use the save as method, part of the SW model variable. Let's define a variable called file name of type string and then put in it our desired save location. The save as method will return a true or false result indicating the success or failure of the saving operation. I'll print the value of this result, and before that I will concatenate it with the literal save as using the AND operator. Let's give it a try. And great, save as is true. Now if you want to save any changes, we can simply use the method save. Generally, after saving a document, you might want to close it, so to do that I'm going to use the quitDoc method from the SOLIDWORKS object. This method requires the name of the document to be closed. We'll use the getTitle method from the SW model_doc variable to get the name of the document. And now let's give it a try. Great. Now to open an existing document, we'll use the OpenDoc member of the SOLIDWORKS object. We will supply it with a file name and the enumeration member for the part document type. Now let's run this and see. Great. We've successfully opened our saved file.
All right, everyone, and just really quickly, I do see that there are some questions coming into the question box, so please keep those coming, and we will actually address and answer any questions that you may have during the Q&A section of the presentation, which is coming up shortly. So please keep firing away the questions in my inbox here. And lastly, the last video, it's about creating extruded features. So Amen, hand it off to you again. What are our members going to learn in this video, and why is it important?
All right, thank you, Bassanio. So in this video, we'll be looking at three-dimensional features. We'll learn about how to use the function extrude, and we'll also learn about how to extrude cut features with the API. So this lesson will introduce us to one of the most important objects in terms of 3D design, which is the feature manager. This is a notable API object that we will be constantly working with when we're designing features, doing cut extrudes, etc. I'll hand it back to you, Bassanio.
Awesome. We'll go ahead and get started.
In this lesson, I'll show you how to create features using the feature manager. Now we have previously created two sketches, each one containing a circle. We will create an extruded feature with the first circle, and then we will create a cut feature using the second circle. This way, we will have the cap part geometry we started earlier completed. Now let's begin this lesson with an empty part document. In the VBA editor, I have the code we wrote in the previous lesson. To start, we will define and set the feature manager variable, so let me do that. Great. Now let's extrude the first sketch to a depth of 12 millimeters, and for that we will use the method feature extruding2, member of the feature manager object. let's jump to the offline help for more context. It's worthy of mentioning that the feature extrusion 2 method relies on ordered lists to distinguish between entities used as extrusion sketch, the direction of the extrusion, and other selected entities used in the creation aspect of the feature. In our earlier lesson, we saw that the parameter mark is used to mark order selections for functions that require them. So this would be a good opportunity to showcase the usefulness of the mark parameter. The remarks section is advising us to select the 3D sketch to be extruded with a mark of 0. It's also noting that the direction of the extrusion should be selected with a mark of 16. We will begin by selecting the first 3D sketch with a mark of 0, and then the front plane with a mark of 16. However, it's also said here that the default direction for boss operation is along the sketch's normal vector. Since our sketch is on the front plane, we don't really need to select the front plane. For the cut feature, it's noted here that the default direction for cut operation is opposite to the normal vector of the sketch. Since our second sketch is in the same plane of the first sketch, we need to set the direct parameter to true to reverse the default direction. We will do that when we create the cut feature. Going back to the parameter list here, the only interesting parameter is called T1, which is the depth of the extrusion. We will give this a value of 12. Alright, let's go back to VBA and put this into code. I'll begin by selecting the first sketch with a mark of 0. Good. Then I'll use the method feature extrusion 2 with SD as true, flip as false, dir as false, T1 as 0, T2 as 0, T1 as 12 millimeters, and the rest of parameters are 0 or false accordingly. Great. Now let me select the second sketch with a mark of 0. Here I'll use the method feature cut3 with SD as true, flip as false, dir as true, T1 as 0, T2 as 0, T1 as 5 millimeters, and the rest of the parameters is 0 or false accordingly. Great. Now let's run through this step by step. And as you can see, SolidWorks is extruding the first sketch to a depth of 12 millimeters. And then the feature is cut to a depth of 5 millimeters.
All right, everyone. So in conclusion here, because we're going to start kind of wrapping things up a bit for time purposes, we really, our goal and the reason why we're doing this is to really empower our members and learners around the world to be able to learn different tools that are going to make you more proficient at your day-to-day jobs and, you know, be able to innovate. And that's really our goal here, and that's why we've chosen to go out and expand our library and created the Content Author Program, where we're working with other subject matter experts to be able to help us bring this courses like this to the table, because you can see just quickly there in that last video how SOLIDWORKS API can potentially automate some of your processes. So that's really important for us and what we're trying to do long-term for SolidProfessor. And, you know, again, our self-paced lessons, exercises, and other materials we have in our library. Again, it all comes back to the goal of helping you be able to learn the tools necessary for you to be more proficient at your job, and this SOLIDWORKS API course is a great example of that. So let us help you and your team. If you're not a member currently, you can sign up right now with this promotional offer, and you can use the promo code there, SOLIDWORKS API 15, and we'll go ahead and get you a 15% off membership. So time for some Q&A. Going to dive into some of the questions, and looks like we have a fair amount. Let's see, we'll start with the first question, and that is, Amen, what were the email addresses that you mentioned in the beginning? Basically your email address, because it looks like we have a member that's ready to reach out to you directly.
All right. So the email address is Amen, that's A-M-E-N @cadhero.com. And you can also reach me via Twitter at _cadhero. You can also go to cadhero.com, where there's a contact form, and you can leave me a message there, and we'll be able to take it from there. Thank you very much.
Awesome. And then also another question, it's more of a comment. Someone said that the second lesson they didn't have a chance to really see. Once again, we will be providing the recording for this presentation to everyone that is registered and signed up. So just be on the lookout for your email. We actually will supply you with a recording, so if you missed a certain portion of it, want to share it with your colleagues, you have that available. Does this course include creating EPDM admins? I do not think it does. I can speak for Amen. Are we creating an EPDM admin course? We actually are in the process of creating a new course for that, so stay tuned. Here we go, Amen. Good question for you. What does the true and false mean in the programming language?
So true or false are basically booleans representing either 1 or 0, meaning that if the return of let's say you have an operation and you would want to know if that operation has been accomplished successfully, for example, creating a document. So functions in programming language can have a return, and that return can be a boolean of type true or false. So if the operation has been completed successfully, and that method will return of true or 1 sometimes, or it will return false if some error or occurred throughout that process, meaning that the document that operation has not been completed successfully. So it's either a yes or a no.
Awesome. Question I'll take is, can I obtain a free student version of SOLIDWORKS software? You have to reach out directly to either a SOLIDWORKS reseller to be able to do that. We don't provide the SOLIDWORKS licenses, or there's a landing page for SOLIDWORKS Direct where you can actually reach out and inquire about the student licenses of the software. Okay, here's another good question for you, Amen. Does your course cover working with SOLIDWORKS custom properties?
Yes, the course has a number of lessons. I think a lesson that covers working with custom properties, dealing with the custom property manager, when you can learn how to get all the custom properties, add custom properties, remove existing ones. So that's covered in the course, yes.
Great. Another question, when the rest of a command is true, false, or 1 to 0, are there really pretty much do you really need to type all of that information in there, or is there a shortcut to keep you from having to type all of that in?
You don't. Well, it depends if it actually depends if the rest of the code is based on the truthness or falseness of the operation. For instance, if you just want to create a document without having to see if it's true or false, you can just specify the command without having to declare a variable of type Boolean and then set in that variable to the return of the method. So you can just type the instruction directly without having to get the return. Sometimes, in other cases where you have to verify if the document has been created successfully, you need to verify the return of the let's say, a function that creates a document. And we use that a lot when we want to see if we want to promote the user with an error message saying, hey, the document has not been created successfully, please try again. So yes, the answer to that is that you don't need actually to set the return of a function to a variable of type Boolean. You can just use the instruction directly. I hope that answers your question.
Okay, what are the applications for the recording feature?
All right, so basically with the recorder record tool, you can record almost any action that happens in SOLIDWORKS. If you want to design a part document, you can just click on record and then you can start designing, and afterwards when you're done you just click on the stop button and then you'll have a file that you can play over and over again with that button. So anything that you can think of in SOLIDWORKS that you do in the graphical user interface can be recorded. So this is only bounded by your imagination of things that you can accomplish in SOLIDWORKS. Almost 99.9% of the actions that you perform in SOLIDWORKS, whether you'll be working on an assembly, you're adding mates, or you're adding a drawing view to a sheet, or you're changing the dimensions of a segment, all of that can be recorded and can be played over again. That being said, I will have to mention that the recording tool is a very good start to learning with SOLIDWORKS API. Obviously, after you progress with this course, you will find yourself sometimes that the recorder macro does not actually fit your needs, and you would want to go further and further. You would want to write your own macros, and that's exactly what the rest of the lessons are about. That just with the recorder macro, it just gives you kind of a sense of the power of the SOLIDWORKS API, and then after you progress through the rest of the lessons, you'll be able to write your own macros, and hopefully in the future, I think there will be more courses to advanced topics with the SOLIDWORKS API. I think Bassanio will be able to provide you with more information on that.
All right, here's a really good question, and I can actually provide a case study specifically. I'll be able to send this to the gentleman who asked this question, but can I get a real-life example of how an API can potentially save someone some time? So particularly a case study, and like I said, I'll be able to provide that. We do have some case studies directly from SOLIDWORKS with the SOLIDWORKS API, but Amen, I think you can speak to maybe a specific case study or example or two of maybe a client or someone that you've helped in the past that you can potentially talk about how an API specifically saved them time and automated a process.
All right, so I can take the example of a recent project I've worked with a customer in the Midwest, where they had a very lengthy process of documenting their machinery. So they're dealing with assemblies at the size of hundreds and hundreds of parts. So for instance, they wanted to explode a function that will automate that will create an exploded view. And you can see for yourself that if you're faced with an assembly that has over 50 parts and you want to explode those components that exist in the part, for example, gradually, you would need a lot of time just to achieve that function. So manually, that takes about, let's say, half an hour, and with with an automated version through a macro or an add-in that takes about only a few seconds. Something else that creating drawing views with the same customer. Actually, we wanted to be able to create drawing views or sheets that contain drawing views of the setup instructions when they're assembling the machinery. And as I said, the number of parts is huge, so the steps are many. So the process of going through the drafting takes a lot of time, and with automation, we've been able to squeeze that down from 6 hours to just a handful of minutes, where the code just goes on, explodes the assembly, and then creates different configurations of each step that will actually each step of the assembly, and then creates the bill of material, etc. So I hope this is a very good example of how the SOLIDWORKS API can actually drastically reduce the time it takes to perform redundant actions. Back to you, Bassanio.
Great, that was a good example. We have time for a couple of questions, one of which is, does the course cover customizing the SOLIDWORKS design checker?
Actually, no, it doesn't cover that. This course is an introduction to the SOLIDWORKS API, and something that I really wanted to point out that this course has that is very, very powerful is the SOLIDWORKS. There are two lessons that cover one of the most, I wouldn't say controversial, but essential topics to learning the SOLIDWORKS API, which are the SOLIDWORKS library and the offline help. And once you go through these two lessons, actually anything that will come with any problem that you have, it will be easier to conquer, because it will give you a very good understanding of how the API, of the mechanics of the API, and it will also give you the best tips as to how learn what this function does, what this object does, and how they interact with one another. Although it's not covered, but I think that these two lessons will give you a really good head start into achieving what you want to do with the tech designer. Back to you, Bassanio.
All right, last question is, what's the difference between a macro and an add-in?
The difference between a macro and an add-in is that macros are usually small scripts. They are limited by the language that the macro is written with. So macros are written with the Visual Basic language, or rather VBA, which is an offshoot of the VBA6 language developed by Microsoft. The difference is basically the language, so you're limited by the feature of the language. With the SOLIDWORKS add-in, you have what we call the .NET framework behind it. So you'll be able to accomplish way much more in terms of possibilities and potential. With the SOLIDWORKS add-in, you can actually add tabs, you can add buttons. The software, the add-in is basically integrated into SOLIDWORKS. Maybe some of you have come across PhotoWorks. That's a SOLIDWORKS add-in that comes with SOLIDWORKS. Some other add-ins that come innate with SOLIDWORKS are additions that SOLIDWORKS, there are additional features in the form of add-ins that makes the environment more, that makes the features more integrated, and it makes it very easy to use these features. If they were to be written in a macro, then the code would be very lengthy, and the process would be very complicated because you're limited by the features of the VBA language. As I said, .NET continues to be improved by Microsoft to this day. With .NET you can write SOLIDWORKS add-in, but with VBA it has stopped a very long time ago. So that's the reason why people now, for very complicated projects, for extensive, for projects that are deal with large assemblies, they would go for add-ins, for something, for learning about SOLIDWORKS in general, for writing small scripts that achieve small tasks. They'll go with the macro because it's easier. It's very easier to test. It's very easy to run. So I hope the two cover the differences between what an add-in is and what a macro is. Back to you, Bassanio.
Thank you, Amen. I actually launched the poll question while Amen was answering that question, and it is pretty much what else would you like to learn? We've added a few items on that list, one of them being GD&T and SolidWorks simulation. Getting some feedback here. Looks like we have about 63% of people voting. And with that, I'll kind of close things out and say, Amen, thank you very much for, number one, helping us with this course and create this course. And then number two, thank you to all of the members that tuned in. Again, this is part of our mission, is to become, once again, this all-encompassing engineering resource. And though SolidWorks API may not be the sexiest tool out there, it will automate and save you a lot of time. So that's why we chose to add this to the library, because it helps our SolidWorks members and users to basically reduce some of the time you take putting in manual tasks and completing manual tasks, so you can spend more time innovating and, really discovering new ways to solve existing problems. So with that, I'm going to close out this poll, and we're pretty much done with the presentation today. So again, thank you to everyone who has joined us today. Again, we'll send out this recording. If you do have any additional questions or your questions did not get answered, we will get to them, and it seems like multiple people in the Q&A section were interested in actual physical case studies as well, so I'll be able to send that to you. So again, happy learning. Thanks again for tuning in, and we'll see you guys in the next webinar. Thank you.